Our last section in this chapter talks about special products. It is almost identical to the things we were doing above. Again, the acronym you need to remember, and it will come back for years, is FOIL. First, outside, inside, last. I would like to review something from the prior lessons. Is we are going to, when you have an exponent outside of parentheses, you need to distribute everything inside. Notice this is a monomial without a plus or a minus sign. That would equal 9x squared. Over here, it is a little different. This is a binomial. Here is our first term. Here is our second term. It includes a plus sign. Therefore, we cannot just simply distribute the two. It is not like a monomial with no plus or minus sign there. Instead, what this means, it would be x plus 3 times x plus 3. And you would need to FOIL, so I get x squared plus 3x plus 3x plus 9. We have the terms in the center to combine. X squared plus 6x plus 9. This answer is known as a perfect square trinomial. We will be working with perfect squared trinomials in the future that we would be able to identify a perfect square trinomial. It's a perfect square trinomial because we took the same binomial times itself. It's a perfect square. For the next one, again, because we have a binomial, we cannot do that. That is a no. You may not just distribute the x squared. What it means is you really have x plus 5 times x plus 5. FOIL that out, I would have x squared plus 5x plus 5x plus 25. Again, I know I did a great job. I have the two terms in the center I can combine. X squared plus 10x plus 25. Because I took a binomial times itself, I have two of the identical binomials. This is also known as a perfect square trinomial. There is kind of a pattern going on here. I'll do another one, and then let's see if we can talk about a special pattern that occurs when you're squaring binomials. Oops, sorry about the camera. I will have x plus 7 times x plus 7. FOIL that out, x squared plus 7x plus 7x plus 49. I have two terms in the center that are alike, so I can combine x squared plus 14x plus 49. All right, let's look at that. Are you noticing any pattern when you look at the original problem, binomial squared, to the solution? Do you notice anything with the numbers and the patterns here? In the last lesson, I tried to say, please don't think of shortcuts. Please don't think of gimmicks, because they do or they don't always work. There is kind of a shortcut with this that will always work if we catch what's going on, and we're going to need to refer to it in later lessons. What I notice is if you take the first term and square it, you take the last term and square it. if I take this last term times 2, I would end at 20x. Well, let's just do a little sidebar and see if that is true. This is a perfect square because I'm taking the binomial times itself, so x squared FOILed out plus 10x plus 10x. Oops, I forgot my plus sign there. Plus 100. Combine the like terms. Ooh, it worked. This will work when and only when you have a binomial squared. FOIL will always, always, always work. Only works with a binomial squared. FOIL always works. So 2 ways to do this. We could say x plus 8 times x plus 8. Notice what I'm saying, that I am not using the word parentheses. We would simply say x times 8, or x plus 8 times x plus 8. FOIL that out. And I get x squared plus 16x plus 64. If I think of this as a perfect square, I would have plus 64. 2 times 8 gets me 16x. Now, let's test and see if that works when I give you a binomial with subtraction. X minus 12 squared is x minus 12 times x minus 12. FOIL that out. Oh, be careful. Negative times negative is positive. Combine my like terms in the center. And I end with x squared minus 24x plus 144. If I see it's a binomial squared, square the first term. Ooh, now you know that that is the second term. Square the second term. 2 times the last term. This shortcut's kind of neat, completely not necessary. Please remember, FOIL works for everything. What I would like you to do is pause the video, and I would like you to do these 6 problems at the top. I will work them out without you, and then we'll reveal answers and talk about it. I would like to walk through some of them when I add coefficients. Please pause the video. Thank you for pausing the video. I started them, but I didn't really complete them because there's a few things I wanted to talk about. And I wanted you to look at that and wonder in what patterns you may or may not have noticed. So x plus 11 squared, I rewrote it out and I FOILed, and I ended with x squared plus 22x plus 121. I could have x squared plus 121, 2 times 11 to get plus 22x. It worked there. Again, I'm not a fan of shortcuts at all. The next one, x minus 15 squared is x minus 15 times x minus 15. When I was done FOILing, combining like terms, I have x squared minus 30x plus 225. Well, notice what I did to you here. I added the coefficient 2. So I FOILed 4x squared plus 18x plus 18x plus 81. Combining my like terms, I end with 36. I wonder if any of the little trick or gimmick I showed you for a perfect square would work here also. I did the same thing here. When I was done simplifying, I had 9x squared minus 30x plus 25. In summary, please know foiling will always work. Oh, this is not a perfect square. I didn't take the square of x minus 4. I have opposites. One of them is x minus 4. One of them is x plus 4. So I had to FOIL that out. I got x squared plus 4x minus 4x. When I'm done combining my like terms, I just get x squared minus 16. These go away. Interesting. On this one, a binomial x plus 13 times x minus 13, they are exact opposites again. I FOILed it out, combined my like terms, x squared minus 169. That's very interesting to me. So can we make a prediction what we would think the answer to this one would be based upon the two examples you did by yourself? What do you notice here when given this? What do you notice here when given that? What I noticed is it would be the first term squared, the second term squared, with a negative or a minus sign in between. Well, let's very quickly FOIL this out and see if that is true. So I would have x squared plus 7x minus 7x minus 49. Combine the terms in the center. Oh, we got the same answer. Again, once in a while I notice a pattern, but FOIL works every time. I gave you a coefficient on that. I wonder how that will impact the answer. I'm going to try this. Because they're exact opposites, 3x plus 1, 3x minus 1. Let's see what happens. I wonder, will it equal that one squared, this term squared, with a subtraction sign because a positive times a negative is negative? Or we can always FOIL 9x squared minus 3x plus 3x minus 1. Combine my two like terms in the center. Oh, that worked again. We will be practicing with multiple variables, but the process is exactly the same. I will FOIL 16x squared outside plus 12xy, alphabetical order, minus 12xy minus 9y squared. Remember, y times y is y squared. Like terms in the center, I end up with 16x squared minus 9y squared. When they're perfect opposites of each other, square the first term, square the second term, positive times negative is negative, we would get the same answer. Oh, look, we have all kinds of things going on, lots of negative signs. In this situation, again, I'm going to go back to FOIL will always work. So I'm going to FOIL, being very careful of all of my negatives and positive signs. Alphabetical order, always and always. All right, I FOILed very carefully. I put terms in alphabetical order so I can see they are alike. Therefore, I can combine them. 4c squared minus d squared.